I speak about lines of Metro São Paulo. I will speak general aspects, historic of our development of projects, trackway special routine is used in São Paulo Metro, civil structures inspection system, and final remarks. The subway line enterprise is very complex and comprehend about the conception, design, construction, operation, maintenance, recovery. And economic evaluation and the global cost is very important along the life of the line. In construction phase, the decision in construction phase will impact in the operation, a big impact in operation phase. This picture shows the bathtub curve, curva della bagnera. Is typical of the beginning of the operation, the problems we have in the beginning of operation of one line. We have early infant mortality failures. This first 5 years of the operation of the lines. And after this, in region 2 of this graphic, is the random or constant failures. Is occurring aleatory, randomic. And in the end of the life of the metro line, or civil enterprise, we have a lot of problems because the structures having problems. This picture show a study by Amberg from Switzerland, indicating the principal, the main problems in tunnels is humidity and water entry along the life. This statistical analysis of pathologies showed a lot of tunnels, 1,710 kilometers in Switzerland, indicating the main problems related in humidity and water entry. In São Paulo, we have now 5 lines in operation. We have the line 4, but line 4 now is privated. And we don't have data about the maintenance of this line. But the line 1 began operation in 1974. We have 50 years, more or less, operation. 23 stations, and line 2 operated since 1991, line 3 1979, and line 5 2002, the beginning of operation. The most part of the lines was underground, or tunnel, or cut and cover. This picture shows the underground stretch in line 1, 16 kilometers, in line 2, 40 kilometers, line 3, 6 kilometers, line 5, 1.2 kilometers. We now are beginning the operation of all the line 5, but we don't have new datas. And 54% of the lines was underground. But we have a lot of examples of problems of durability, in special related to watertight or loss of the watertight. Cracking, leaching, infiltrations, efflorescence, hydraulic retraction, cracking, damaging equipments, electrical and mechanical equipments, damage in the tray, damaging in track and fixations, false occupation. False occupation is a very serious problem in lines of São Paulo Metro, because we are transporting 4 million people a day. If one train stops the operation, we have a lot of problems in platforms, in the stairs, and others. And if water stay on the track, our system indicated a train stopped in this position. In our system indicated false occupation. We call it the ghost train, this situation. Other problems, track switch damages, problems of ceilings at the shield precasting rings, environmental problems, problems of health, fungi, pain, sensory discount of user, aesthetic aspects, and the others, aggressive water in concrete, chemical attack in structures. And we have in mind now this sitter rule. The sitter rule said, if you use one money in the project, in design period, we can don't use 5 monies in execution or 25 monies in maintenance or 125 monies in corrective maintenance. In this point of view, it's better use money in the design period or execution. But, because in the end of the period of the life of the tunnel, we will spend a lot of money. This is one example of use of maintenance costs. In these cases, line 2, line 3, line 5, we use it in 7 years. 1,500,000 preparation of injection of high special polyurethane resin for temporary tank. Preparation and injection of polyurethane resin for final sealing. 43,000 liters. Very, very expensive. Preparation and injection of polymeric acrylic gel. 30,000 liters. These costs is paid by the user. It's not paid by the construction. We prefer now spend money in design to not in this situation. This is the graphic about the meta. Meta is a very important concrete specialist. And this graphic indicated the problems in the concrete life and the problems with the water in cracks, problems, loss of mass of the concrete, problems in the arms, corrosion. And the cost of waterproofing to prevent this kind of problems in São Paulo today is this order of money. In line 5, the waterproofing is 80.7 of the cost of concrete, all the concrete of the line. And waterproofing related to all the work of the line, 3.8%. And in line 2, the waterproofing cost 7.1 related to concrete, and 2.8 related to all the work. If you have in mind the sitter rule, this is 1 or 5. If we don't use this project philosophy used in project, we will use 5 5 vezes mais, 5 times in maintenance or recuperation of the lines. The problems of waterproofing in the world, our data indicate the first uses in 60s using reinforced fiberglass and flexible membranes was used in polypropylene textiles and polymers in Switzerland and Austria. And in 1983, NITM in Washington, using membrane, flexible membrane with a big success. And after this, a lot of works around the world are using flexible membranes. But in São Paulo, our waterproofing systems, in lines, the first line in 17th, we used only layers of asphalt. A big 7 layers, asphalt, JTES style, asphalt, JTES style, high cost of the deployment, difficulties of application, limited durability. These pictures indicate the sequence of construction of waterproofing in line 1. The success of this option is not very good because a lot of these tunnels are over the water table. It's difficult to indicate this is a good solution. And around the world is now a very old solution. Application very, very difficult. In years 80s, in line 3, a new philosophy in São Paulo Metro, low permeability concrete. In this case, used in stations in Agabaú, República, Santa Cecília, Marechal, and the others, without waterproofing, active structure, low permeability concrete, and localized treatment of possible leakage points. Success less than desirable. A lot of problems. In Marechal Deodoro Station, and this tunnel is NATM tunnel with 2 layers, shotcrete layers, and without waterproofing. Partial success in these conditions, because in this tunnel, the mass is a very good clay without water. But in other stretches, a lot of water in the tunnel. One important view of this option is that we construct with low permeability concrete. The concrete is impermeable between the cracks. Is the important. In the cracks, the water inflow to the tunnel. Impossible in our situation, our technology. But in line 2 green, without waterproof 2, using TBMs in concrete rings and shotcrete. We had a lot of problems of waterproofing using only shotcretes. This left figure down is indicating a tunnel with technical rooms, a lot of transformers, electrical, and control systems. We need to reconstruct all the faces of the tunnel using mortar, a polymeric mortar. Looks like we will make a pie. The mass, how can I say, artisanally. But the climax of the bad situation of waterproof was in Vila Madalena Station. Vila Madalena Station was constructed by NATM method in a geology very variable with layers of sandy clay in the top right of the picture. And 3 different levels of water table. But looks like now we have a lot of stopped works. This tunnel is stopped during 6 years with a big shaft connecting all the water tables. And the construction of this station without waterproofing, using low permeability concrete. A lot of problems. We had problems with the public ministry, processing the justice, a lot. Problems, serious problems of leakage and the others. The picture you can see a lot of situations. The pathologies, infiltration in retraction cracks and the thermal region, infiltration concrete joints, infiltration concrete failures, nest and voids, the dissolution by hydrocarbon of asphaltic membrane in contact of line 1. In summary, low permeability concrete is efficient between fissures, and the repairs is very, very expensive. This is a repair of the Vila Madalena station. It's similar to odontologic situation. You need to open your tooth and use mass polymeric. This is a situation. But after the problem, we had a good situation, but all years new cracks showing. Years 2000, we changed the ideas. Now we are using waterproofing. This is the first use of waterproofing. Looks like in this period, the indication is CIA 280. 218, Switzerland norm. This group, this shaft was waterproofed by a group from Switzerland to use perfect the first utilization of this. This is a shaft with PVC membrane, 2 millimeters, using water bars, double welding, testing the depression in the welding. This is a station, Alto do Ipiranga station. The section of this station is 302 square meters. It's a big station in soil without one drop of water. The final station operating now. After this, we use it a lot. This is station Luz, line 4, all sandy, without one part of clay. Water, we had 70 watt shafts through dewatering to construct the station, and use, in this case, 3 millimeters PVC membrane. Now, in line 5, we are using, in all projects, PVC membrane. This is line 5, new projects. The construction of a station Brooklyn. This station is a special station for us because it's an application of 5 second shafts. Constructed in some time all the shafts using diaphragmal walls and hydrophrase in this case. But in the face of the operation, because our company constructs and operate the lines, we have a very specific procedures to inspection. This is a kind, I had a help of group of maintenance of the metro. And the maintenance, a lot of things. One, track. Systematic inspection in tracks. The wear of the tracks, using pantography system, measure with mini-proof device, topographic inspection in all the lines, in special lines where we are constructing new tunnels under the lines. Leakage current inspection is a serious problem. We had problems in corroded fixations, and in the buildings around it. If we have a lot of leakage current, had problems in the around of our line. Ultrasonic inspection in tracks, general inspection and cleaning, washing the tunnels, using underground water, where the old lines, we have points with a lot of water. We are using this water to washing the tunnels. Lubrificator and the track switches, track lubrificators, systematic inspections, grading rails in all the lines periodically, and in some points special, we have problems in the rails. In this case, we change the tray rails and the grinding rails. Track switches, we have track switches in wooden sleepers or directly on concrete. Now we are changing all the wooden sleepers to concrete sleepers. But is a point very important to maintain. Schedule maintenance with component replaced and trackability records, in special in the track switches. Special systematic of track switches and monitoring of track switches. All this monitoring is very important because if one train stopped in the platform with 2,000 people, it's a chaos in São Paulo, chaos. welding rails using fusing, changing rails, transport of the rails in the tunnels, rails exchange, aluminothermic welding, same, electrical safety, inspection of 30 rail of electrical alimentation, disconnect switch the third rail, lamps of maintenance in the tunnel. Now we are changing all the lamps to LED, lighting in LED. Indication looks like Holland indicated. We have emergency signaling in all the tunnels, indicating the emergency exit and the balizement of the tracks. Emergency signaling. It's a very important point for us, noise vibration attenuation. We had the first problem we had in MASP, Museu de Arte de São Paulo. We had in years 19, because the trains induced a vibration in the concert room of the museum. During the concert of camera with violoncello, the vibration of the train. Beginning in this situation, we need change all the fixation systems where needed. Fixation of this is a special kind of noise vibration. It's a mass spring system with helical springs. It's called isodampers. This is for frequency 5 Hertz. It's the more expensive and is the best system of noise vibration. The structural reliability of São Paulo Metro, the subway facility must prevent a level of structural reliability compatible with network operation responsibility. The main basic prioritization must always be a minimization of structural problems, detecting visual inspection at any way, which may compromise the stability of the installations, the good efficiency of the equipment, and above all, the safety and physical integrity of user and the employers of subway. In summary, the basic prioritization of the city civil maintenance service related to operation, basically refer, guarantee of full operation of trackway, operation of network without affecting the so-called carousel, the São Paulo Metro operating carousel, the integrated flow of the train operating network, continuous power supply of metro network, ensuring full and sufficient signaling during the commercial operation, guarantee of operation of user access system, box office, collection, and the locks. This is the flux of the inspection in the trackways and the structure of the tunnels. This maintenance is civil maintenance is only in finishing elements, structures, corrective maintenance, infiltration treatments, failure of waterproofing, and anomalies in concrete. We have the track vehicles to promote this maintenance. The cracks, concrete borders, joints of rings, concrete joints in NATM, problems in walls in cut and cover stations, joints beam wall in cut and cover stations. Common point of all these problems, no waterproofing with membrane in these cases. Only with the low permeability concrete like waterproofing. NATM wall, NATM station, the same problems. We developed a system to study and hierarchize the problems using cameras in vehicles, in tracks, filming all the structures, the tracks, the walls, the tunnels, and was filmed and create a special sheet. This case is sheet of the emergency way. All emergency way is precast concrete. And we have tunnels with 40 years. And we need to inspect all the plates, all the plates. We using filming, and after this, classificate kinds of plates with problems, big problems, small problems, and or changing the plates. In this case, infiltration in the superior photo and photo without problems down. The following figure shows the result of the evolution of the conservation status through the assessment of notes of the steps in the decision-making process of maintenance floor plates. It's an example of emergency emergency way. And the surface of the elevated tracks of subway, floor plate surface, walls, and highways. The finding of this study indicated part of the plates need inspection than 5 years. Other part inspection best 2 years. Substitution of 80% of the plates and in 2 years, and I don't know, 4% immediate substitution. This is an example of this use of the system. This system is called the Malberman. Is a company was contracted by Metro to inspect all the structures. In this case, NATM, a stretch of tunnel, we had the anomalies in first inspection, 90%, 9.7% normal. In second inspection, normal 43%. The problems are growing during the years. And the resume of this, the abstract of this is in stations, for example, Station Santana is an elevated station. Carandiru elevated, JTES, and the others. The main problem is the stations elevated or at level, we have more problems than underground stations because the rain, the acid attack of the rain, the atmospheric attacks, and more or less 20% of the problems was in underground structure, but 80% of the problems is the in level or elevated structures. Conclusion of this study. In view of all the situations investigated, it is noted that some structures present deterioration process more accelerated than others. The structure exposed directly of the action of the weathering and the main rainwater was present great evolution of the quantity. I said this. In abstract is this. This case, in this table indicates stations, elevates undergrounds, surfaces, and cycles of inspection necessary after the system of control. 5 years, cycles of inspection of routine, in some cases, 5 years, 8 years, depends the kind of structure. Closing inspection line 5 and 2, we used waterproofing in all stretch of tunnels. Our design action, I mean a durability of 100 years, and returning to the sitter rule. If we are using one in design phase, we use 125 in the maintenance phase. Using the PDCA, I think all people know this graphic. When a continuous improvement process, maintenance and work control feedbacks are important for the project because they bring lessons learned, which will subsidy the new projects. Considering that the Metroway line development do not finish at the delivery of the work, but continues in the operation phase, there should be true in a structure and their respective waterproofing system with the less cost of maintenance through the life of the system, overall operating cost of the line. This is important if we consider a system management with resources of public administration. Therefore, you must think on a maintenance project with little or no corrective intervention during your life and with technical research to make the inspection and conservation of the civil structure. One indicates bibliography.